Hello everyone, let us solve today's Geeks for Gifts problem of the day. And the problem statement says make array elements unique. We are given an array, we need to make each element of the array unique. That means there cannot be occurrences, more than one occurrence of the same number. Just like 122 is not possible, so we need to make some operations there. The operation is defined as this. In an operation, a value can be incremented by one only. There are no two types of operation. There is very less complicacy in the problem. Okay, so let's understand with an example. We are given is the array as suppose 1 2 2. Okay, 1 2 2. If I travel from this side, then I stand at here, one is fine, then I'll see this 2 says that no 2 has appeared before, so 2 is remains as it is, and this 2 says that I have seen another 1 2 before, so it will become 3, and one increment operation is required here. Okay, because this 2 became 3. Okay, if I take a bigger example, suppose 1 3 3 3 4 4 5 6 7. Okay, if I travel from this side, 1 then 3, then this 3 says that I have seen one guy like me before, so it will become 4, and this will become 4. At first try to increase by 1, 4 has already appeared, so 5 will come here. Then this 4 has seen 4 before, so it will try to increment it by 1, it will become 5, but 5 has already appeared, so it will become 6. In this way it will become 7, it will become 8, and it will become 9, and it will become 10. Okay, so we here we can see that one brute force approach can be sort the array, and at first sort the array, after that iterate like this, and standing at a point I'll make increments until the point an element which was not appeared before appears at that position, just like 1 1 1 1. So it will be 1, then this one will become 2, this one will first become 2, but 2 has already appeared, so it will become 3. This one will become 2 at first, then 3, then 4. So in this way increment until the point which element was not appeared before. So in this way we can solve, but this brute force won't work because the elements can go up to 10 to the power 9, and it will easily give us time limit exceeded verdict. How to save ourselves from that? For that reason we can take some extra space. Although the question says that we cannot use extra space, but let us think about using some extra space at first. So one thing you can observe that I have taken sorted arrays only. I have not taken unsorted arrays, because in case of unsorted arrays the visualization is difficult, and also sometimes means actually we cannot go to the constant space solution using that unsorted array. So sorting is the first part, and we also have this time complexity given, so n log n can be achieved using sorting is fine. Okay, sorting is okay to do, so it's okay. The first of all, let us push the element which was appeared before 1, then this 3 comes and 3 is appeared, in the set and this tree in. So if the unordered cell is there, then it will be on an average big of one time complexity, and if um, set is fine set, then it will be log n operation, but if still it will be n log n time complexity. That's a good thing. Okay, n log n will pass. Okay, so tree says that I have seen myself before, so it will increment itself by one, this 4, and this 4 will now be pushed. Now this tree sees that 3 has appeared before, it will see that 4 has appeared before. So this movement we can omit it. How to omit that thing? To omit this thing, we can just see the biggest element present in a set. So for the same reason we can use a max if also, but that implementation will also be of different type. Okay, so for that reason I will increment the current element uh, up to the biggest element present in the set plus 1, and you can see this pattern and you'll find it intuitive if you do some dry run. Okay, dry run the code. And then 5 has already appeared, then now this element will see, and the biggest element present in the set is 5, so it will become 6. Okay, it will become 6. Okay, so this is the way of doing things, and we can now move on to the final part of the video, which is we basically need the constant space solution. So sorting is necessary. The first part is sorting. Now we need to solve it without using extra space, and we need to have the array again. So I am drawing it 4, 4, 5, 6, and 7. Okay. Okay. So for the reason, the pattern I see here is that whenever the previous element is greater than or equal to the current element, then increment it by this plus 1. Okay, so that condition will do a mass for us. Okay, then 1 comes here, then 3, then this 3 says that I have my previous element is 3, so it will become 4. So and in the same way it will become 5. We need to have a monotonically increasing array. So 5, 6, 7, 8, 9, and 10. So that's it. We can now implement the code. So how we have got this without using extra space solution? So that part is really very intuitive, because we only have one type of operation, which is increment operation. Whenever some element which has appeared before, then we have only one option: increment until the point whenever the condition has not been satisfied. Okay, for that reason we can in constant space increment one more than the previous if the condition is violated. And that's all for this video. You can write on the code later for understanding purpose, but I think it is easily understandable. And let us see the final implementation of the solution. Okay, that's it. Because without sorting, we cannot write a code like this. Previous element cannot be seen. If I have 765, so previous element condition is not okay. If the elements are mixed 7, 3, 5, and 6, then 7, then suppose 4, 4. If the elements are like this, then we cannot do this type of operation. So sorting is necessary. After that, we will C from the second element only, because the first element will always be satisfied, which is very intuitive to understand. Okay, now the answer can be very large, so it should be long answer equal to 0, initialize at 0, answer. So the implementations are only required when error I is less than or equal to ARR I minus 1. Okay, then only we'll take the answer plus equal to ARR I minus ARR I minus 1 and increment one more than the difference. Okay, that's fine, and the current element will become ARR I minus 1 plus 1. Okay, and in the end return answer. Okay, at first sort the array to do the operations in smooth way and for attaining the extra space solution. Now increment whenever the condition is violated. Okay, that means the current element is less than or equal to previous element. Okay, that's fine, but I have written this is wrong because the previous will be bigger or equal, so subtraction will be there. I can use absolute also, but why to make complicacy unnecessarily? Okay, that's all. I'll compile it, submit, and you can see we get accepted verdict, problem submitted successfully.